course, we're going to be learning how to use a formula to find how much we need to deposit so that we have a certain amount of money at the end of a designated period of time. So today we're going to be talking about present value. Present value means that the current value of a deposit that is made in the present time. The present value of a single deposit investment and the present value of a periodic investment, those are two new applications. We're going to two new formulas that we're going to learn how to use so that we can solve for deposits or periodic deposits instead of the ending balance. Present value of a single deposit investment means one deposit. We can use this formula or this concept. If we say we need $100,000 in 15 years, this formula will allow us to compute how much we need to deposit today, so we'll have $100,000 in 15 years. One deposit, how much that it will allow us to find that, and that is the present value of a single deposit investment is the value for how much a one-time deposit should be at a specific interest rate in order to have a certain amount of money saved for a future savings goal. Sounds confusing. Really what we're saying is here there's an investment, there's a formula that will allow us to compute what we need to deposit today if we have a designated amount of money that we feel like we need to have in the future. The next one is basically the same thing, but now it would be a periodic investment. So we learned about periodic investments earlier in this unit. A periodic investment is the same amount at regular intervals, right? And so now, if we want to be able to earn a specific or accumulate a specific amount of wealth using an investment, but we want to make regular deposits, that's what this formula is going to be for, and that is the value for how much to deposit on a regular or periodic basis at a specific interest rate to meet a future goal. You caught up with me? All right, a few more seconds. We'll have time to come back at the end if you don't finish up in the next few seconds. All right, so we're going to talk about our first new formula. So, what's different and what's the same about this formula and the other formulas we've been using? The variables, are they the same or different? Yeah, the variables are all the same. We have a P, an A, an R, an N, and a T. Right? We've been using all of those, and they seem to be the same things here. What's different about this one and all the others that we've talked about, learned about? Very good. So the we've been solving for that ending balance, but now we're solving for the P, the principal or the beginning balance. So, I'm going to see if I've got that copied and pasted. So now we're going to look at an example of a problem that we would use this equation for. It says, Mr. and Mrs. Johnson know that in 6 years, their daughter will attend state college. She will need about $20,000 for the first year's tuition. How much should the Johnsons deposit into an account that yields 5% interest, compounded annually, in order to reach that amount? So what we're saying is, they know they need $20,000. What they don't know is how much they should deposit given this interest rate and the amount of time they have. So now, this formula that we have will let us do that. So we know it's a single deposit. It does say compounded annually, but it's only one deposit. If it were more than one deposit, it would say every week, or every month, or monthly, or quarterly, right? So we should know, because they're asking how much should they deposit. When the one that says how much should they deposit, that is the clue that we're using the formula solve for P, that we can solve for P for. So make sure you indicate this is what you're looking for. Because you got all these formulas we're going to be testing on Tuesday, right? So how do you know which one to use when? If they're asking for you to compute the deposit, it's going to be one of the ones from today. The P equals something. This is if they only deposit once. So you guys should be able to identify your variables from this problem. Forgot what I walked over here for, but I remembered. Not what I wanted. What'd you get for the A, Kaylee? What'd you get for the A, Hayden? 1,000. Yeah, so that's the ending, that's the future amount that they want, okay, Kaylee, does that make sense? We're solving, we shouldn't, this is the one we don't know, so that's a little bit tricky. Normally our question mark has been with the A variable. Now the question mark is going to be with our P, or our beginning balance, and that's going to represent the deposit. You may want to make a note that that P is the deposit, right? Might be a single deposit, might be a periodic deposit, but we're looking for the deposit, so that's when you would use this formula. And what's the rate going to be? Kaylee, can you help me with that one? Yes. And what's the N going to be, Riley? What's the T going to be, Kiana? Good. So that's stuff, we've been doing that. The only thing that's different is these two, right? So now, instead of A, we're writing 20,000. Instead of R, we're writing 0.05. And 1, we're plugging it into our formula, amount. So in order to get credit, remember, you need this, and you need to show me that you plug those variables into the formula. We are going to practice entering in our calculator. If you did not get a calculator today, make sure you do. Go ahead and get it now. So she needs $20,000, and she's earning interest. One of the things you're looking for, if you get an answer and it's more than $20,000, that's not going to make any sense, right? Also, well, it's kind of hard to gauge how much smaller it needs to be. So let's go. You guys go ahead and try to put it in on your calculator once you get it entered in your formula. Enter it in your calculator and see what you get. Darius, did you write the formula down? All right, you plugged everything in here? No? Okay, that's what we're supposed to be doing, buddy. So, when you plug it into the formula, this is what you need to get. So at this interest rate, in 6 years, they can earn over $5,000. So all they have to do is deposit a little less than $15,000, and in 5 years, they will earn $5,000 for doing nothing but putting it in this instrument. So that's a pretty good increase on their investment. So if you're not getting 14,924.31, I am going to put the keystrokes up on the board so you can see. So on your calculator, you're entering 20,000 divided by, there's brackets here, but there's no brackets on your calculator, so we're going to put 2 parentheses. So parentheses, parentheses. Now, 0.05 divided by 1 is just point. I'm not going to do that math when there's a 1 there, so I'm just going to put 1 plus 0.05. Now our exponent button, that caret, and 1 times 6, I can do that math in my head. And then I need to close the parentheses and press equals. I'm going to double check that I wrote the keystrokes right. You guys double check and see if you got the same answers as on the board. Yep, they work. You guys get it? Any questions? So it's a pretty good deal. You loan somebody your almost $15,000, and in 5 years they give you back $20,000. That's a pretty good deal, right? If you can afford to be without that money for a while. Anybody have questions on this problem? Well, let's go ahead and go to the next one. So once again, these are a little bit easier because we know which formula we're supposed to be using, right? But you really need to look for these clues and concentrate on this when we start reviewing for our test tomorrow and Monday. How do you know which formula to use? Well, Amber just graduated from college. She wants $100,000 in her savings account after 10 years. How much must she deposit? So that tells me I'm looking for the formula that I'm solving for the deposit or the beginning balance. And it tells us it's compounded daily in order to meet her goal. So this is the formula. We should all be able to identify our AP, R, N, and T, and you need to do that on your homework in order to get credit for it. Jada, what'd you get for A? Perfect. What did you get for P, Jakaya? That's right. That's our question mark, right? What did you get for the R, Daniel? Perfect. Now that one's tricky, remember, because a lot of kids get confused because there's a decimal in the percent, so they think that's already the decimal. We use our rate as the percent as a decimal, so don't forget that has to be divided by 100. That's 0.0095. What's the N going to be, Zaire? 365. Yes. And what's the time going to be, Danny? 10. And now we're plugging it in. We're replacing the variables with the values that we've written here. So this is what your formula should look like once you've plugged it in. Kamara? That's like texting in class, right? Are we allowed to do that? I know, but we're not supposed to be doing that, right? Okay. you get it entered, let's try to plug it in on the calculator. I will show you the keystrokes. Let's try it on our own first. See what you get. What'd you get? Mason, what'd you get?
90,937.40.
Okay. It should be 41 though, right? But that's good. Except you get, it's .07 or 9 or something, so you're going to round up there. But yes. Everybody get that? Anybody need me to write the calculator stroke? All right, anyway, because this is my video period this time. So on the calculator, we're going to enter 100,000 divided by, remember the fraction bar is divide by, left parentheses, 1 plus .0095 0095 divided by 365, close up parentheses, our exponent button, and now left parentheses, 365 times 10, close our parentheses, and equal. If you didn't get the right answer before, try that and see if you get it. Get it? Good. All right, y'all ready to go on? Okay, so those are two examples on a single deposit. Situations where we want to be able to determine what we need to deposit one time so that we have a certain amount of money at the end of a period of time. Now the next formula, the same thing, we want to determine the amount we need to deposit, but we want it to be a periodic deposit this time. So $500 every month or $200 every month. We want to be depositing over time, regular intervals. What we want to know is how much should we deposit if we want to have $25,000 in 3 years or $125,000 in 10 years. What should those deposits be? Right? It depends on all these variables here. I'm going to copy and paste that. So once again, the P represents our unknown deposit. So you might want to make a note because that's how you're going to have to determine which of all these formulas you have in your notes, which one do you use on which problems in your test. It's a lot easier in the homework because we've narrowed it down to only 1 or 2 formulas, right? But on the test, it's going to be, you have the option of picking all the choosing from all the formulas, and that makes it more challenging. So it says Bob wants $50,000 at the end of 7 years in order to buy a car. If his bank pays 4.2 interest compounded annually, how much must he deposit? So now we know we have to use one of these formulas as the P. So how much must he deposit? And now here's the phrase that tells us it's periodic, each year. So we knew it was one of the 2 P formulas. Now we know it's this one because it's periodic. It's regular deposits at regular intervals. So the same deposit amount at regular intervals. So once again, we've been identifying all these variables for a long time now. So let's go ahead and do that. And then plug it into your formula. And then see if you can enter it on the calculator to be very important that you write your formulas on your work paper, because we know how challenging and how you can make a mistake entering on the calculator, and I don't want you to miss all your points because of that, right? If you get one keystroke wrong on a test in the notes today and in your homework, you're going to be able to confirm you have the right answer, right? But on your test, you're not going to be able to do that. So make sure on your test you're identifying your variables, you're showing me how you plug it into the formula. What did you get for A, Kari? What did you get for the P, Lucy? What did you get for the rate, Deanna? Good. What did you get for the N, Tekiria? 1. And what did you get for the T, Lila? Yes. And so now, in all these places, where there's an A, we put our value that we've identified. Where there's an R is, we put the value we've identified. And it should look like this. Not if you show me your work. If you don't show me your work, I may or may not. It depended on the last test. I can't remember. Sometimes I didn't do credit, and sometimes partial credit, and sometimes I did. And I can't remember exactly what the difference was, but it basically boiled down to what I saw on your work paper. If I could see on your work paper that it was just a rounding issue, then I only took up a point, or some version of a point on that problem, right? But if I wasn't sure that you knew what you were talking about, and I looked at the answer, and at your work paper, and you had nothing there, you might have missed the whole thing. So if you did not get $6,292.16, we need to make sure you know how to enter it so you will. Did you get that, Therese? Did you get that, Bria? Yes. Daniel's still working on it? Okay. Lauren, did you get that? Yes. And you put the calculator strokes again. So on your calculator, you don't need these parentheses here, I will tell you. These are not necessary. You can put them if you want. 50,000, left parentheses, 0.042. If this were some other number, I'd divide here, but it's 1, so I'm not. I'm going to hit equals. You don't actually have to do that either, but I like to do that before I hit divide. So I'm going to divide left parentheses, right here. 1 plus 0.042. Once again, if that were some other number, I would divide there. Our exponent button. If we had to multiply something, I would use parentheses, but it's just 7. Minus 1, you have to put this right parentheses. So the thing you should be looking for is making sure you have the same number of left parentheses as you do right parentheses, because that will mess you up. I've got 2 left here, I've got 2 right here. And don't forget you need your equals. So if you enter it like that, you should get $6,292, and you're going to round to that 6. Any questions? I see there's a person or two still writing the calculator strength. We're going to go on to the last example. If you're still struggling with the calculator strength, we only have one more example. You have time to come up and sit with me and we'll enter it together, okay? We're going to go into our last example. It says Mary wants to go on a $10,000 vacation in 1 year to the bank account that pays 4.25% interest compounded monthly. How much should she deposit each month to meet her goal? So how do we know when we're not specifically doing an assignment on this, which formula use? Well, the fact that it says how much should she deposit. So if that deposit is unknown, that's how we know we're using one of these present value formulas, the ones that start with a P. So go ahead and identify the variables that we want to plug in. Oh, did we finish reading it? Yeah, we did. So go ahead and identify your A, P, R, N, and T. We know it's a periodic deposit. She's going to deposit each month. So she wants $10,000. So she wants her ending balance to be $10,000. We're using this formula so we can solve for the deposit. That's the P. The rate, 4.25 divided by 100 is 0.0425. Compounded monthly. So what's the N going to be, Zakaya? Perfect. There's 12 months in a year. The N stands for how many times it's compounded in a year. And T, it says 1 year, so T is 1. So we're replacing all of our variables in this formula with the numbers that we've written here. So once you've plugged it into the formula, go ahead and try entering it in your calculator. This is what it should look like in the formula. I prefer you try it on your own versus just copying it, but that's what it should look like. What did you get? Perfect. So it's money, so let's put a dollar sign at least in our notes. So if you got 817 and you don't need the calculator stroke that I'm about to write, you can go ahead and scan and submit your notes, and then get started on the 4 problems on the back of this worksheet. The notes, go ahead and get those turned in now. There's a reason those turned in now. And the worksheet we're going to do tomorrow at 7. I will write the calculator strokes up here. Just to see the problem. calculator strokes there? Okay, so you have time. Honestly, these are not going to take very long. You know which formula you're using. One of the hard parts tomorrow and Monday are going to be determining which formula to use. So make sure you bring all your notes tomorrow. I think I am going to let you guys start making a formula sheet to use. I don't know, I might have one already. I might tell Miss Taylor. Maybe I have one already, but it's still good for you to make one because that'll help you remember which one you're supposed to use, even if I do give you a formula sheet.